Welcome. So in this video I am going to solve some more problems related to logic topic. The first thing that you need to do, in case if you are new to the channel, please do subscribe the channel and share with all the students who are taking this course. So let's start. The first question is that let Qx and Px be the statement X is a professor and X is ignorant respectively, where the domain consists of all people. Then the logical expression for all x, Px and negation of Qx is equivalent to. So it will be what? For all x, Px means Px is the statement X is ignorant, and negation of Qx will be X is not a professor. So all are ignorant and not professors. So that will be the correct statement, because this is what they are saying, that for all x, X is ignorant and X is not a professor, means all are ignorant and not professor. Okay. Next, P or Q, both way implication by conditional statement. Negation of P implies Q is equivalent to. So how to solve it? P or Q and by conditional statement, negation of P and Q can be written as negation of P, right, or Q. What result I have used? I have used the result that P implies Q is equivalent to negation of P or Q. So here, since it is negation of P, so I will be taking negation of P or Q. So this will be equivalent to what? This will be equivalent to P implies Q by conditional, and negation of P is P or Q. So now both of them will have the same truth value, so the by conditional will be true, and hence it will be a tautology. A very simple question. Next, let P be the statement P is that n is even, statement Q is that 3n plus 8 is even, then which of the following is true? So I am not going into the detail, but you can prove it directly, that if n is even, then 3n plus 8 is even, that is by the direct proof. And using proof by contraposition, you can prove that if 3n plus 8 is even, then n is even. So the statement C will be correct. P implies Q and Q implies P both. So here C will be correct. I hope you can do it. Now if you look at this problem, consider the following compound proposition given as, and actually they have given 3 propositions, 1, 2 and 3, and they are asking me to verify that which of the following propositions are not tautology. So don't miss this not here. So let us look at the first one, P or negation of P and Q, right? So this is equivalent to what? This is equivalent to P or using De Morgan's law, I can write negation of P or negation of Q. Now I can use associative law, so P or negation of P or negation of Q. Now this will always be true, right? So this will be equivalent to true or negation of Q. So that will be a tautology. Now the first statement is a tautology. Now I am going to look at the option. I am not going to check the other option. Why I am going to look at the option? They are saying that which of the following propositions are not tautology. So certainly since one is tautology, that option all can't be correct, because this one is a tautology. And since one is a tautology, the option this and this can also not be correct, because it is saying that 1 and 3 are not tautology, it is saying 1 and 2 are not tautology. So since only one option is left, so I am ticking that option. I am not actually going to write the detail that whether these are tautologies or not, but to understand this, I would certainly request you that verify that whether these two are not tautologies, right? So clearly the first option is a tautology, so the correct option will be B. I hope you got this point. The idea that I have used, that even though I have not shown about the statement 2 and statement 3, since I already know that the first option is a tautology, using the options I can verify. Now the next question, what is the negation of the statement Sam is rich and happy? So it is and, so if I take the negation it will become or, and its negation Sam is rich, its negation will be Sam is poor, and negation of Sam is happy will be Sam is unhappy. So either Sam is poor or unhappy, so the C option will be correct. Now look at this correct question, which is a slightly better question. Select the appropriate option after evaluating following 4 biconditionals, whether these are true or false. So you know that biconditional statements are true when both P and Q are going to have the same truth value. So if you look at the first statement, 2 plus 2 is equal to 4 if and only if 1 plus 1 is equal to 2. So 2 plus 2 is equal to 4 is true, and 1 plus 1 is also equal to 2 is this is also true. So this will be a true statement, right? This will be a true statement. The second one, 1 plus 1 is equal to 2 if and only if 2 plus 3 is equal to 4. So this is false and this is true, so this statement will be false. The third one, 1 plus 1 is equal to 3, false if and only if monkeys can fly. So since monkeys can't fly and 1 plus 1 is not equal to 3, so both are false, and false if both are false, then the biconditional statement will be true. If I look at this, if 0 is greater than 1 if and only if 2 is greater than 1. So 0 is not greater than 1, so this is a false statement. So this will become false. 2 is greater than 1 is true, and 0 is greater than 1 is false. So 1 is false, another is true, so it will be a false statement. So here we are getting 2 statements to be true. So they have asked select the appropriate option after evaluating following 4 biconditionals are true or false. So we have noticed that 1 is true and 3 is true. So which option will be correct? The option A will be correct. Only 1 and 3 are true. Now let us look at this problem. If x and y are integer of opposite parity, means one is odd and another is even, then 5x plus 5y is. So I think you can easily verify this, that if I say x is suppose I say even, so if I write x is equal to 2k1 and y is odd, so if I write y is equal to 2k2 plus 1, then what will be 5x plus 5y? So 5x will be 10k1 and 5y will be 10k2 plus 5. So this I can write 2 times 5k1 plus 5k2 and plus 2 and plus 1. So since k1 and k2 both are integers, so this will also be an integer. So twice of this means this is an odd. So what option will be correct? So the correct option will be A, because it will always be odd, right? Now go to the next question. Contrapositive of the statement, if you are honest then you are respected. So suppose I say you are honest is P and you are respected is Q. So what is this is a statement P implies Q. So its contraposition is negation of Q implies negation of P. So negation of Q is you are not respected. So you are not respected, and negation of P is you are not honest. So the B option will be correct, that if you are not respected, then that is not than, this is then, spelling mistake, then you are not honest. So the B option will be correct. Yes. Now next, let the statement P dogs can fly and consider the following flow chart of a computer program. So we are taking the value of R is equal to 5 and P and negation of P. So P and negation of P will always be false. So if they are saying that this is true, then S will be defined as R into R plus 5. But since this is false, so it is defined as S is equal to 0. So what will be the value of X? Because we are moving in the direction of false, so S is equal to 0. So C will be the correct option. An easy problem. I don't think it requires much effort. Let us look at this problem. What is the correct translation of the following statement into mathematical logic? Some COVID-19 vaccines have completed the last trial and are ready for production, where X is the COVID-19 vaccine. I think there is a mistake here. TXX has completed the no, means here they are expecting they are giving that domain. So it was better if they would have written domain is equal to all COVID-19 vaccine. So TX is that X has completed the last trial and PX is X is ready for production. And what is the statement? Some COVID-19 vaccine have completed the last trial and ready for production. Means there exists some X which has completed the last trial, means Tx is true, and ready for production. So ready for production is Px. So which option will be correct? There exists X, Tx and Px. So this option will be correct. The option C will be correct in this case. Now consider the following statement over the set of integer. P, k is even, q 3k plus 1 is odd. Then which of the following is true? Means since we are going to select just one option, so I need to look at them in that way. So what is the first one? Only converse of the statement P implies Q is true. Now we know that if we have a statement like P implies Q, its converse is written as what? It converse is written as Q implies P. And how do you write its inverse? You write it inverse is negation of P implies negation of Q. And we know that the converse and inverse are, you know what do you call? They are equivalent statement. So we can prove that if k is even, then 3k plus 1 is odd. So that is the original statement. If I write its converse, means I have to prove that 3k plus 1 is odd, then k is even. So that can be proved by using the contraposition, the rule of contraposition. So it is easy to prove. I leave that for you to prove. So Q implies P is true, and since Q implies P is true, so negation of P implies negation of Q is also true, because both of them are equivalent statement. We know that. This is an important observation. I think those who have watched the previous video, they will agree that P implies Q is equivalent to its contraposition, that is negation of Q implies negation of P. And converse and inverse of the statements are also equivalent to each other. So which option will be most appropriate? Both converse and inverse of the proposition P implies Q is true. So the correct option will be C. I hope you got it. Now this question is just a memory based question. There is nothing special about this. Which of the following can be used to disprove the statement? So we know that the counter example is a strategy which we use to disprove the statement. So to prove anything, any number of examples will not be sufficient, but to disprove something, one example will be sufficient. So counter examples are used to disprove the statement. So here the correct option will be C. Now let us look at this. Consider the following three statements. P1, A is less than B. The statement P2, the average of A and B is greater than B. And P3 is the statement, the average of A and B is greater than A. So A is less than B. Suppose I take A is less than B, and if I now take A is less than B, then I can consider that A plus B will be less than B plus B, and this will also imply that A plus B by 2 is less than B plus B, means B plus B by 2, so I can write directly is less than B. So it is saying that the average of A plus B is less than B, but P2 is saying that average of A plus B is greater than B. So certainly P1 is not equivalent to P2. Now if I take A is less than B, then I can write A plus A is less than B plus A, and if I divide both sides, so A plus A by 2, let me write A plus A by 2 is less than B plus A can also be written as A plus B by 2. So from this we get what? We get A is less than A plus B by 2, which is nothing but A plus B by 2 is greater than A, means average of A plus B is greater than A. So that is the third statement. So we noted that P1 and P3 are equivalent to each other. So the correct option will be B. P1 and P3 are equivalent, right? Next, which of the following statement is equivalent to if x is equal to 3, then x square minus 9 is equal to 0? We know that this is a conditional statement. P implies Q. So conditional statement is equivalent to its contraposition, means negation of Q implies negation of P. So if I take negation of Q, x square minus 9 is equal to 0 will become x square minus 9 is not equal to 0, and negation of P will be x is not equal to 3. So the correct option will be C, that if x square minus 9 is not equal to 0, then x is not equal to 3. So I hope you are getting this question. Okay, so now let us look at this problem. In which one bracket inserted correctly for the proposition? So now if you look at this statement or this proposition, here they have not put any brackets, but they want you to write it in such a way that all the brackets appear at the right position. One important observation is that here this notation they are using for negation, right? So before I solve this question, I quickly want to recall that in one of the previous videos in the logic topic, we have discussed about precedence of logical operator. So there are different precedence that we associate with them. So first precedence we associate with the negation operator. The second precedence we associate with AND. Third we associate with OR. Then fourth precedence we associate with conditional, and in the end we consider biconditional. So the negation is given the first precedence. So basically we will take the negation of R first, right? And then we associate precedence with AND. So I will write AND Q. So this is the first bracket we need to place here for this. And we associate third precedence to OR, so we write P OR, right? Now here in this side, if you look, this AND gets the higher precedence, so I write S and R, and then gets the precedence conditional statement, so I will write implies P. And in the end we this is the biconditional, so it gets the last precedence. So if I have to write, I will put one extra bracket over here. So this is how it should look like. So which option is like similar to this? I can see that the first option is similar to this, so the first option will be correct. I hope you understood this concept of associating importance. Precedence or importance means which gets the first preference. I hope you are not confused with the word precedence. Preference you can also use. Now let us look at this problem. In proving under root 5 is as irrational, we begin with the assumption that root 5 is a rational in which of the type of proof. So in direct proof we start with under root 5 is an irrational, so it is not correct. We start with this proof by contradiction. So when we have to prove something, we start with the negation of it, and that process is known as proof by contradiction. So I think it is a very obvious memory based question. You have understood. Now if I look at this question, which of the following theorem can't be proved using direct proof? So we have to look at the statement one by one, and in case if you have seen our proof related video, we already have discussed this kind of thing. But anyway, just to give you some idea, direct proof means we start with the first statement, like if I have to prove P implies Q. So in direct proof we start with P and we show Q. So if you look at the second option, if n is an odd integer then n square is odd. So I will start with n is an odd integer and I will be able to prove n square is odd. So here we can prove it by direct proof. They are asking which of the following theorem can't be proved. So this can be proved. If m and n are integers and both are perfect square, that mn is also a perfect square. This can also be proved by the direct proof method. So this is also not a correct option. Sum of two odd integer is even. So here also we can take two odd integer and their sum will be even. So that all these three options can be proved using the direct proof method. But this one can't be proved, that if n is an integer then 3n plus 2 is odd. Then n is odd. If n is an integer and 3n plus 2 is odd, then n is odd. This can't be proved using the direct proof method. So for this we have to use the proof by either contraposition. So if I take n is even, I will be able to show that 3n plus 2 is even. So the correct option will be A. So this statement I can prove using the proof by contraposition, which is an indirect proof method. Now there is a concept of restricted domain. So if I ask you that restricted universal quantification for all y not equal to 0, y cube is not equal to 0 can also be written as. So this is also a kind of memory based question, that for all y, if y is not equal to 0, this implies y is not equal to 0. So the correct option will be C. right? I hope you have understood it, because for all y, so certainly I have to these two symbols, these two options contains there exist, so either C or D, but here they are restricted domain is there, so for all y not equal to 0, y cube is not equal to 0 will be the correct statement. Now if I go to the next question, let me see what is the next question. Question number this. So what is the what will be the value of x in a computer program for the expression if x is less than 2 implies x is assigned a value? This symbol is used for assigned x plus 1 if x is equal to 1 is encountered. So if x is equal to 1 is encountered, then x1 is less than 2. Since 1 is less than 2, then x will become what? X will become x plus 1. So this 1 will become 1 plus 1, which is equal to 2. So the correct option in this case will be B, right? Next question. For all AB in S, which of the following statement holds for the expression? For all AB is equal to BA, means they want to write here equal, means you know that matrix, if you multiply matrix A into B, then B into A. And our matrix class, in our matrix class we have studied that matrix multiplication in general is not associative, sorry, not commutative. The commutative word I am trying to use. So the matrix multiplication in general is not commutative, but there may be situation where the matrix multiplication may be commutative. It is not like in general it is not commutative, but there may be situation where the matrix multiplication AB and BA may be equal. So always true is certainly not correct. Always false is also not correct. There exist situations, means they wanted to use this symbol, there exist, where A and B are such where AB is equal to BA may be true. So the correct option will be C. I hope you have understood this, that matrix multiplication in general is not commutative, but in some specific cases it may be commutative. So the correct option is equal to C. I hope you got.